So in this question, we're given two integer arrays, nums1, nums2, both sorted in non-decreasing or ascending order, and two integers m and n, representing the number of elements in nums1 and nums2 respectively. We need to merge these two arrays into a single array sorted in non-decreasing order, and the final sorted array should not be returned, but it should be stored in array nums1. And we know that to accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, the last n are set to 0 and should be ignored, and nums2 has a length of n. So we know that if we merge nums2 into nums1, there wouldn't be any extra or less than characters. So in this case, we have nums1 equals 1, 2, 3, and nums2 equals 2, 5, and 6. So if we merge them in increasing order, we would first need a 1, then a 2, then another 2, then a 3, then a 5, then a 6, and that is the resulting array. So in order to do this with an algorithm that runs in O of m plus n times, that means we basically need to be able to merge nums2 into nums1, where you traverse nums2 and nums1 m plus n times. So if we were going to merge them, since there are 0 characters at the end, it will mostly be very efficient to be able to put the largest numbers at the end first and then go down in descending order. So basically, if we were to write this out real quick, we have 1, 2, 3, 0, 0, 0, and then we have 2, 5, 6. So basically what we'll do is we'll start here, and if we put, so we know that 6, so if this is our array, 1, 2, so we know that 6 is the largest between the two arrays, so we can put 6 here and basically cross it out since it's not being used anymore. And then we can decrement to this one and point to this character, and we know that 5 is greater than 3, which we would put here. And then decrement to this, and then we know that 3 is greater than 2, so we can put 3 here. And just to make sure you understand, this is not like a separate array that I'm creating, this is just nums1. This signifies nums1. We're just showing this as like a separate thing to visualize it better. So that now we have, we're here, so the next character would be a 2. So we can take this 2 and put it here. That'll be an x. And then 2 is greater than 1, so 2 will go here. That'll be an x. And then since we're left with 1, we'll basically have that here. And we have traversed both the arrays appropriately. So this in code would be the last index equals m plus n minus 1, and this will signify how we basically traverse nums1 from the last element all the way down. Then we need to create a while condition to make sure that we don't end up going beyond 0 when going down nums1 and nums2. So basically, if nums1 at m minus 1, which is going to be the largest current value in nums1, and if it's greater than nums2 at n minus 1, then at nums1, the last element would equal nums1 m minus 1, since we want the largest element at that last position. Then we can subtract last by 1 and m by 1, and then this would just be the opposite condition. Minus 1 and last minus equals 1, and minus equals 1. Instead of decrementing last here, we can decrement it outside the if conditions. So one thing that we didn't account for is if, for example, we have leftover elements in nums2. So in this case, we can see that if we end up so if we end up with any leftover elements in nums2, then we would just have to merge them into nums1. So while n is greater than 0, nums1 at the last element equals nums2. And this will ensure that all the elements are present. Oh, and this condition must be flipped.